Welcome to EDU World Space.
So in this question, we are given a machine part that is made of titanium, right? So this titanium and a critical point in the material is subjected to plane stress such that the principal stresses um, are sigma sub 1 and sigma sub 2, that is equal to zero point 0.5 sigma sub 1, right? Now we are required to determine the magnitude of sigma sub 1 in megapascals, right? That will cause yielding, right? And now there are two parts, right? The first part is that we need to solve it using the maximum shear stress theory, right? So let's start with its solution. Now the solution is very simple, right? So if you look at page number 881, where there are table and charts, we find the yield strength for the material to be equal to 924 megapascals, right? And we are given this relationship. So if we rewrite this relationship, we have sigma sub 2 is equal to 1 divided by 2 sigma sub 1, right? We have written it in the form of a fraction. Now, for the first part where we need to solve it according to maximum shear stress theory, so for that we would want to use equation 10.27, right? And since sigma sub 2 and sigma sub 1 have the same sign, so that is why we are using this equation. Now, according to this equation, sigma sub 1 is equal to the yield stress and sigma sub 2 is also equal to the yield stress. Now, this above means that if any of the two principal stresses reach sigma sub y, the material fails, right? So this is the failure criteria, right? We can say this. So therefore, we want the highest principal stress to be equal to the yielding stress, and since the other one will not make the material come closer to the failure, and in our case, it's sigma sub 1 is greater than sigma sub 2, right? According to the relationship that is already given to us. So it's safe to say that sigma sub 1 is equal to the yield stress, and that is equal to 924 megapascal, right? So this concludes our answer for the first part. Now we need to solve it using the maximum distortion energy theory, right? So for this theory, we will use the equation 10.30, right, in which we have that the square of the yield stress is equal to the square of um, the principal stress 1 plus the principal stress 2 and negative the difference of the product, negative the product of these stresses, right? Now what I'm going to do over here is that I'm going to plug in the given value of sigma sub 2 in terms of sigma sub 1, right? So I'm going to plug it back over here. So I'll have 1 divided by 2 sigma sub 1 square, right? Negative sigma sub 1 into 1 divided by 2 sigma sub 1, right? Now, what I'm going to do is that I am going to simplify this equation, right? So I have sigma sub 1 square divided by 4 negative 1 divided by 2 sigma sub 1 square, right? Now I'm going to simplify it. So I have the yield square of the yield stress is equal to sigma sub 1 square, right? Divided by 4, and over here I have 4 negative 2 plus 1, right? So this is the yield stress is equal to the sigma stress sigma sub 1, right? right? So that is 3 divided by 4. Now, as you can see over here, we have this square. So it means that we need to take the square root. So this means that the yield stress is equal to under root 3 divided by 4 sigma sub 1 square, right? So just plug in the value of the sigma sub 1 and we would have my mistake. I did. All right. Before taking the square root, I had to rearrange it, right? So it means that here will be the value of sigma sub 1 and 4 divided by 3, and this would be yield stress, right? Now we have the value of the yield stress. Just plug it back over here and we'll get that sigma sub 1 is equal to 1.0699 into 10 raised to power 3 megapascals, right? And that is approximately equal to 1.07 gigapascals, right? So this concludes our answer for the second part of the problem.